right, welcome back to Hot Topics. This next topic we're going to cover, which Alex calls algebraic symbol manipulation, we realize is probably the most difficult topic in this section.
Right. When we taught this topic, we found that almost every student got stuck here. So we're hoping that this particular hot topic will make this a little clearer and hopefully get you through this so you can continue working at Alex.
Absolutely. It's not meant to be difficult, but we realize that when you're looking at a bunch of words on paper in Alex, it can get tough. So we'll go ahead and get started with a basic one here. This first one, F equals ma, force equals mass times acceleration, for those of you that love your physics. This is just a simple problem, and what we're doing is we're solving this equation for A. Now, some students think, well, when I solve it, do I come out with just one term, an answer, a number? And actually, no, you're going to come up with an algebraic expression for A. So here's what you want to look at. First of all, if you're trying to get A by itself, you ask yourself, what is being done to my A? Well, M is being multiplied by A. Well, just like if you go back and replace this with, say, 10 equals 5x, if I said, okay, how would you solve this problem? All of you would know, well, you divide both sides by 5. Well, in essence, that's all we're doing here, except we're dividing both sides by m. That is the opposite of multiplication. So since m is multiplied by a, to undo it, we divide because m over m is 1. And that leaves us with our final answer, a equals f divided by m.
Right, and just to reinforce Jerry's point, that is the answer. So your answer to these problems won't be numbers or won't be a single letter. It'll be some sort of algebraic expression. That's one of the hardest things for students to get. But if you understand that, I think it might make these a little easier.
Okay, this second problem, you'll notice, has a fraction. Now, just like we did back in Chapter 1 early with solving equations with fractions, we said get rid of the fractions first. That's what we're going to do here. Now, you'll notice there is only one denominator, so we're going to use that denominator and multiply both sides by 2. So that gives us the new problem, 2a equals, now notice 2 times a half, the 2's cancel, and it leaves you with 1 times bh, which is just bh. Now in this problem, we are solving for b. So to get b by itself, h is being multiplied by our b, so we undo it by using division.
Right, and notice this is exactly similar to that first question. We have something equals something multiplied by something else, and so, again, to solve for it, we just divide.
That's it. Now, notice h over h cancel out, so your final answer is 2a divided by h equals b. All right, so now let's progress to where you're at. This third problem you will see is probably starting to relate more to what you're looking at when you're in Alex. Again, we have a fraction, but now we have another expression. But notice that expression is being multiplied by the fraction. Well, step one is just like we did last time. We need to get this fraction out of here so that we can then address the variable that we're solving for, which is f. So, to undo this fraction, again, is always using that reciprocal. So we're going to multiply both sides by 9/5. Now, this gets a little confusing for some students. By multiplying by 9/5, this c on the left side is actually in the numerator. So our new problem becomes 9c over 5. And the right side, well, these all canceled out to 1, and we realize that 1 times anything is itself, so you can actually drop the parentheses and you're left with f minus 32.
Right, so the whole key step to this one is multiplying by that reciprocal. Remember, when you multiply any fraction by its reciprocal, you get 1, and that was our goal. Our goal was to clear the fraction.
Okay, now, from this point, all I need to do is move this 32 over. So to move the 32, I'm going to add 32 to both sides. That gives me the final answer of 9/5 c plus 32 equals f.
And notice you can't combine those because they're not like terms. 9/5 c has a variable, 32 doesn't. So that is the answer. Again, you can write it as 9c over 5 or write it as 9/5 c. I believe Alex will take it either way. We should also mention that this is the formula that lets you change Celsius to Fahrenheit temperature or Fahrenheit temperature to Celsius, just in case somebody walks up to you on the street and asks you.
Good point.
Yeah.
This last one is almost identical to some of the ones that we know drive most students crazy.
Yeah.
So we're going to try to make
Yeah.
your life a little bit easier here.
Yeah, this is a tough one.
The first thing I'm going to do is rewrite this because this does get a little bit messy when we do the first multiplication. Now, Alex will ask you to solve for any one of these four variables. It might be y1 on this problem. If you have to do it again, it's y2, or it's x2 or x1. Whichever variable it's asking you to solve for, they all have the same first step, and that is we've got to get rid of this fraction.
Right.
So to get rid of it, just like we've done before, multiply both sides by the denominator. Now in this case, the denominator is a binomial. And Bill, do you want to tell them?
Right, a binomial has two terms, and that's why we're calling it a binomial. Also, the other thing I want to mention is the subscripts here. Don't get thrown by the subscripts. Sometimes in mathematics, because we want to keep using the same letter, in this case both x and y, to distinguish between two different types of x's, we use numbers. So we call the first number x1 and the other number x2, first number y1, the second number y2. But in your mind, it's just like these were four different variables, A, B, C, and D, or L, P, R, and Q. Don't get thrown by those subscripts. Just keep copying them down and carrying them along and try to ignore them as much as possible. And I think you'll find that then this problem is not quite as distracting as it sometimes is when you first look at it.
And another part with regards to the binomial, you can never take a piece of it and multiply out by it. When you have a binomial, you must multiply both sides by that entire term in order to move forward. So in this case, once we multiply out, you will see that the x2 minus x1 cancel.
Right, they're identical, so you can cancel them. You can only cancel them if they're identical, but they are.
That's right. So now, on the left side, you might say, well, do I need to multiply this out? And our answer is no. Leave it as m times x2 minus x1, and the order doesn't matter, but it seems more proper when you put the m on the left side, equals y2 minus y1.
Though, if you did multiply it out, your answer would still be counted correct by Alex. I just want to mention that. It's just easier not to.
That's right. Now, we're solving for y1. So now y2 is actually being added to y1. So to undo it, we're going to subtract y2 from both sides. Now again, there are no like terms here, so you have m x2 minus x1 minus y2 equals negative y1.
But we don't want to know what negative y1 equals. We want to know what y1 equals. So
that's right. So your last step to get rid of a negative on a variable here, you know that you've got to divide by negative 1. Now, dividing both sides, or in this case, you can multiply both sides by negative 1, basically changes not only this term here, but it's going to change your second term there. This, Alex will require you to multiply through, and it'll give you the final answer of negative m x2 minus x1 plus y2. I think we chose the hardest one we could do.
Right, we tried to pick one of the harder ones of these four, but we hope that whatever problem like this you get in Alex, if you watch this video maybe a couple times, hopefully you'll be able to follow these steps and do it. And again, once you've done this once or twice, I don't think it'll be trouble again. You'll be able to do it from then on.
No, and don't forget, in your textbook, pages 34 and 35 have several more examples written out with the same terminology we've used here today. So hopefully use that, use your master student, use your instructor, and keep moving on.
And we'll look for you in the next hot topic.